Hello everyone, welcome back to my channel. In today's video, we are going to implement a complete M.Tech Thesis level deep learning project that is brain tumor detection using CNN. So this is highly useful for M.Tech students specializing in artificial intelligence, machine learning, computer science, biomedical engineering, and medical image processing. So we will be implementing this project step by step using Google Colab and the MRI brain tumor image dataset that will be downloaded directly from Kaggle inside the notebook. So first of all, we need the dataset for our brain tumor detection project. So we are using an MRI brain scan dataset that contains images of both tumor affected and non-affected brain tissues. So since public datasets links are often restricted or deprecated, so we are downloading the dataset directly from Kaggle using API inside the Colab. So you can see that here. This is what I'm doing is, so these are the Kaggle steps to download the dataset, and here you can see that our dataset is inflating. So this ensures that the dataset is automatically available in our working environment, and here you can see that our dataset is downloaded and extracted. So it contains two folders, one for tumor and one for non-tumor images. We have imported the libraries, TensorFlow. You can see here TensorFlow for building the CNN model, image data generator for pre-processing the image dataset, Keras layers like convolution pooling, flattening, and dense layers, and Matplotlib for visualizing the model performance. Okay, so now we move to the data pre-processing step. We use image data generator to rescale the pixel values of all MRI images between 0 and 1. So this normalization basically helps improve the training performance of the CNN model. We also split our dataset into 80% and 20%, and the training data is used to train the model. So while validation data is used to evaluate the model performance on unseen images. So now here, let me explain you how we are building our CNN model. This is the most important part. So CNN is basically a deep learning architecture that is widely used in image classification tasks. It consists of multiple layers such as convolution that is used for feature extraction, max pooling for dimensionality reduction, flatten layer for converting 2D features into 1D vector, and dense layer for final classification. So the final output layer uses a sigmoid activation function to classify whether the MRI image contains a brain tumor or not. Okay, so the next step is training the model. So now we train our CNN model using the training dataset. We train the model for multiple epochs so that it can learn tumor and non-tumor patterns effectively. During training, the model tries to minimize classification error and improve its prediction accuracy. So you can see that here we are running the model for 10 epochs. So now let's just see the evaluation. Let's analyze the results. So once the training is completed, we analyze the performance of our model using the accuracy graph that displayed on the screen. So in this graph, the blue line represents the training accuracy of the model and the orange line represents the validation accuracy of the model. We can observe that the training accuracy increases steadily with the each epoch. So this indicates that the CNN model is successfully learning meaningful features from the MRI brain tumor images. Now, if we observe the validation accuracy curve, we can see that it lies between approximately 75 to 86%. So the validation accuracy represents the performance of the model on unseen data that was not used during training. Since the validation accuracy is reasonably close to the training accuracy, it indicates that the model is generalizing well and not simply memorizing the training data. However, we can observe a slight gap between training and validation accuracy towards the later epoch. So this indicates that the presence of minor overfitting in the model. So overfitting occurs when the model performs extremely well on training data but does not improve at the same rate on unseen data. This can be reduced by using techniques such as dropout layers, data augmentation, or increasing the dataset size. So overall, the CNN-based brain tumor model has achieved approximately 85% validation accuracy on unseen MRI images. So this basically conclude that the deep learning model is capable of effectively uh, generalize between tumor and non-tumor brain groups, such as Such a model can assist in automated medical diagnosis systems or early detection of brain tumors. So, this deep learning based approach can be integrated into intelligent healthcare systems to support medical professionals in accurate and timely brain tumor detection. So, this was the implementation of brain tumor detection using convolutional neural networks. If you're working on your M.Tech thesis, research paper, medical image processing project, or need help with deep learning implementation, you can check the collaboration details in the description below. Thank you for watching, and I will see you in the next video.